Okay, this is for part 1. As you can see here, we already construct the circuit for part 1. So for the input, we set as the switch for the input. This here we set KA, and then for this switch we set KB, and then for the output for the circuits, for this LED we set as a C, and then in the middle here is B, and then for the last one here LED A. So we want to try the circuits to test the result like in this diagram. So for here now, for like this, right, 1 1 1 it is actually C is 1, B is 1, A is 1. So for right here, it will go 1 1 1 and then 0 1 1. It keep repeating the loop. The condition is when we not press the switch, it will follow the red arrow here. That's why it in this loop 1 1 1 and then 0 1 1 and then keep repeating itself, because the switch is not pressed, so the red arrow will take place. So when we press the switch, it will go out from this loop, and then the blue arrow will take place. Let's say if we press at 0 1 1, it will go up from this loop, go to 1 0 0, and then follow the blue arrow. So we will try it. So let's say we press the switch at 1 1 1, so it will go to 0 0 0 and then follow the blue arrow like this. So try again at 1 1 1, go here, and then go back to 0 0 0 again, then keep repeating as the switch is pressed. So let's say if you want to release the switch at 0 0 0, so the expected result will be from 0 0 0, it will go to the 0 1 0, follow the red arrow here, go to 0 1 0, and then go to 1 1 1, and then go to the 0 1 1, and then go back at 1 1 1, and then keep repeating itself. From here, go here, and then go here, and then go here, and then repeating itself here. So let's try. Wait. Here you go. Here, 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 here. As you can see, it repeating in this loop. So let's say if you want to, when I press at 0 1 1, it will go to 1 0 0 and then follow the blue arrow again. Let's try. We press at 0 1 1. Okay, for the second one, I want to release the switch at 1 0 1. So the expected result will be it will stuck in 1 0 1. It will stuck here, follow the red arrow. So let's try. As you can see here, it's stuck at 1 0 1 here. So when we press again, it will follow the blue arrow again. So for the third one, I want to try release the switch at 1 0 0. So when we release the switch, the red arrow will take place. So 1 0 0, go to 1 1 0, and then go to 0 1 1, and then go to 111 and then go back to 011. Keep repeating here. So let's try. We release at 100 here. See, it's it repeating in this loop. So let's try again. To jump out from this loop again, we press the switch at 111. So it follow the blue arrow again. So for the last one, we try release the switch at 001. So the expected result, it will stuck at 001 here when the switch is released. That's right, at 001 here. See, as you can see here, C is 0, B is 0, A is 1. So this is for part 2, number 2 here. As you can see here, we construct the circuits. So now we want to test the circuit using 8-to-1 multiplexer and the NAND gate. So here, this is the truth table for these circuits. So let's try it. Before that, we set 4 input in this circuit. We set 4 input, which is A, B, C, and D, and then we set 1 output for this, which is F here. So let's try it. When A is 0, B is 0, C is 0, D is 0, the output is 0. So when A 0, B 0, C 0, D 1, the output stays 0. And then for this one, when A is 0, B is 0, C is 1, D is 0, so the output stays 0. When A is 0, B is 0, C is 1, and then D is 1, so the output is 1. And then when A is 0, B is 1, and then C is 0, D is 0, so the output is 1. The output is 1. And then when A is 0, B is 1, C is 0, and then D is 1, the output still 1. And then for A is 0, B is 1, C is 1, and then D is 0, so the output is 1. And then when A is 0, B is 1, C is 1, and then D is 1, the output is 0. And then when A is 1, B is 0, C is 0, and D is 0, the output is 1, as you can see here. And then when A is 1, B is 0, C is 0, and D is 1, the output is 0. And then when A is 1, B is 0, C is 1, the output is still 1 here. So when A is 1, B is 1, B is 0, C is 1, and then D is 1, the output is still 1 here. So next, when A is 1, B is 1, C is 0, D is 0, so F is 0. So when A is 1, B is 1, C is 0 and then D is 1, the output is 1. So, and then when A is 1, B is 1, C is 1, D is 0, the output is 1 here. And then when C is 1, D is 1, C is 1, and then D is 1, the output is 0. So as a conclusion here, the output is depend on D. So as you can see here, when we compare D and F for inode, when D is 0, F is 0, and then when D is 1, F is 0. So the output is 0. And then when for I1, when D is 0, F is 0. When D is 1, F is 1. So it's a D. So the output is D. So for I2, when D is 0, F is 1. When D is 1, F is 1. So the output is 1. So as a conclusion, the F is depend on D. So
Right?
This is for part 2, number 3 here. So we construct a circuit for this, and then as you can see here, we set the input. We set 3 input, which is A0, A1, and A2 here, and then we set one output. So this is the truth table for part 2, number 3 here. So let's try it. When 0 0 0, if 0 0 0, it will be 0. So if 0 0 1, it's the 0, and then 0 1 0, the output will be 1, and then for 0 1 1 0 1 1, the output will be 0, and then for 1 0 0 1 0 0, the output is 1, and then 1 0 1, the output is 1, and then when input is 1 1 0, the output is 0, and then if the input is 1 1 1, the input is 0. That's all.